All right, so today I'm starting up the wiring of the Resolve-EV VCU. This is basically the control unit that's going to control all the Nissan Leaf original equipment, all the stuff that we've installed in the truck. You know, obviously the motor is going to be controlled by the inverter, so this controls the inverter. This tells the chargers when to turn on and off. This controls the battery BMS and receives all the info from that. So this is the new brain of the vehicle, basically. This also outputs to your relays, so your brake lights, your reverse lights, your fan, radiator fan, and a few other things. Also, your throttle output, or your throttle input comes into here from that Volkswagen throttle that we installed. And this also sends a signal to the little LCD screen or LED screen that tells you all your battery info and what gear you're in and things like that. So this is really important to the vehicle. Basically, it will not run without this. This is also an awesome product. At least it should be. I mean, I can't say for sure until I get it running, but the features that it has and just the ability to use all of the parts from a Nissan Leaf, from the chargers, you know, the normal charger and the Chatamo fast charger, to using the motor, forward, reverse, full power, brake lights, reverse light. Like, it's a great product. So I'm really excited to get it put in. Also, he's coming out with features in the future to control things like the air conditioning and possibly some other features that the Nissan Leafs also have. So this is really important to the whole project, so it's important that we mount it securely. So my plan is to mount it here. This is a Tuffy kind of center console type thing. It's got like a big cavity in there to put all sorts of stuff, and it's not mounted. I need to mount it to the chassis. It's like a universal fit. But I think what I'm going to do is mount my Resolve VCU down here. Probably the other way around, so the wires come out the bottom, or maybe come out the top and then curve down to the bottom. I haven't decided yet, but that way it's nice and convenient if I need to pull it out to do updates, because this has a USB port and you can do updates to it, assuming that updates come out, which I'm sure there will. And that's just a nice safe area that's going to keep it protected from, you know, moisture and any damage, and it's just going to be right here. Also, in the instructions, it says that you want this to be mounted as close as possible to the buttons that you use to send it into drive, neutral, and reverse, and it needs to be mounted as close as possible to the OLED LED screen. So for those reasons, I'm going to mount it here in the center console. Also, you could probably mount it up underneath the dashboard where the original ECU for this vehicle was mounted, but I think that I'm just going to do it here because I think it's going to be really cool. So we'll get into it. I'll show you a little bit about what I did here on the Resolve unit. So I marked out already all of the wires from the instructions. So like, for instance, this bundle here is for the throttle. This bundle here is for your drive, neutral, and reverse switches. This bundle here is for the OLED screen. You know, you've got like your ignition on, your chassis ground, battery positive, and inverter and water pump relay. So some singletons there. And then like these are all the wires that go to the PDM. And also you want to make sure that you get your twisted pairs and find your twisted pairs and get those nice and twisted. So like these are the twisted pair that go to the inverter, and these twisted pairs are for the CAN, the common area or close area network, and they're closed area network, one of those networks. But basically this sends a really delicate digital signal, you know, back and forth, you know, millions of times a second or whatever. Probably not that fast, but really fast. And they need to be twisted to keep down any interference and maintain that signal strength. So like you can see, I've got the twisted pairs that go here to the BMS, and you just need to make sure you read the instructions, get all those twisted pairs, bundle up the wires, and then it's really not a big deal. A lot of people will like read a wiring diagram and they'll look at this and their eyes will just cross and they just won't have any idea what they're doing. It doesn't have to be that difficult. Start with the basics, just one at a time, go through each pin, mark what they are, bundle up the common ones, just simplify every job one by one, step after step. If you try to take in the whole wiring diagram, the whole schematic all at once, you're gonna just lose your mind. But like his instruction sheet here is just super detailed, super easy to use. Like, see, he calls out the can, so make sure that you twist those pairs. Just super easy to read, detailed instructions. So I'm just gonna fly through this wiring. I think it's gonna be one of the easier parts of this project. So let's get stuck in, let's do some wiring. Awesome, now the Resolve is mounted down in there. I got the wires, harnesses separate, so I can go ahead and wire all these up with tons of flexibility and then plug them in when I'm done. All right, moving on. So wiring for a lot of people can be kind of scary or challenging or daunting. Some people even say it's insurmountable. They'll never learn wiring. But for me, it's really easy. I love it. I think it's a lot of fun. It really satisfies my OCD to trace every wire to its point, make sure all the terminals, all the connections are perfect. That just really does it for me. In my previous life, I built and flew drones, and a drone, like a quadcopter up to an octocopter and bigger, it's just a EV that has 4, 6, 8 more motors. So it's just one of these, but more complicated. All the connections have to be perfect. The solder joints have to be perfect. You can't have any stress or fatigue on the wires because then they'll get damaged over time. And all these things is really important because otherwise the drone can fall out of the sky and it might hurt somebody or damage some property. So I'm going to apply all those same philosophies and techniques to my Land Cruiser conversion. And really all of my electrical work that I do, I apply these principles because especially with the DIY EV conversion, the safety of this vehicle, the reliability, it's all gonna come down to how well you do these solder joints, how well you do your crimp connectors, which wire that do you choose to use, how you choose to protect that wire, where you choose to run it, because these wires is the lifeblood of the car. And one thing that these electric cars have is called a CAN, or a closed area network, or a closed area network. So what that means is that they're sending these really delicate signals along these wires, and they're traveling pretty far distances, 6, 8, 12 feet in a vehicle like this. And you've got to make sure, first of all, that you use a twisted pair of wires that are twisted together. Personally, I'm going to use not only a twisted pair, but a twisted and shielded pair. So that looks like this. So it's a twisted pair of wires, and it also has this aluminum foil sheeting on it. And that is going to block out any kind of outside interference from those wires. So I'm going to use this type of wire for all of my CAN bus connections. For my throttle, for instance, I'm going to be using this, which is a pro tip, is a USB extension cable. So all sorts of us, like we have tons of USB cables just lying around, stuff for, mini USB that no longer is used on anything, all the way up to these extension cables, which are really high quality. And USB wire is perfect for running these sorts of sensors like I'm going to be using for my throttle sensor. So you can see in this USB cable we've got 4 unshielded conductors here, and the green and yellow, the green and white is a twisted pair. Then we also have 2 sets of twisted pairs here that are also shielded, and they also have looks like yeah, they also have a ground run along with them. So this is really awesome. I'm going to use probably just one of each of these twisted because it's not needed for the throttle, and this is also a shielded cable, so just like the other cable, this will protect it from any outside interference. Now this is not required. The instructions don't say you have to do this. The only thing that they say you have to do is make sure that you use a twisted pair for the CAN bus. The reason I'm doing this is I've got this wire, and these are really handy because it's got a nice thick durable cover on it, and it's got all the connectors in there, so I just have to run this one wire versus running 6 individual wires. In some cases running 6 wires is just fine, but for me I'm just going to use this. I've also got some high quality power wire for the VCU. This is a 14 gauge, so it's going to supply plenty of current. Now one thing you want to know about automotive applications is a lot of times you'll find silicone wire. Now silicone wire is really great. We use it all the time in the drones, but I would not recommend it in a vehicle like this. I would recommend good old-fashioned PVC shielded wire. Now silicone has higher temperature, that's true. It can doesn't change shape when it reaches high temperature, that's true. It's smoother, it slides easier, that's true. But there are some downsides. For instance, if I just take these scissors here and I just kind of scratch along the surface of this wire, no problem. It doesn't even hardly mark the PVC. Okay, so now I've got some silicone insulated wire, and I'll do the same thing. I'll just slide it really gently across there, and you can see it's already starting to come apart. I hope that's showing up, but you can already see the copper strands in there. And if I put a little pressure on it, it's going to start tearing, and that tear is going to propagate. So that's why I don't recommend using silicone insulated wire. Just use good old-fashioned PVC. Right, wasn't that fun? So now we've got it all wired in. What I'm going to do now is double check every single connection, then I'll shrink that heat shrink. I've got a ground tab here that I want to put a lug on for to ground the shielding, because the shielding doesn't do much. It does some stuff, but it's better if you ground one end of it. If you ground both ends of it, then you can have some issues with some other things, but just ground one end. I'm gonna do that. Put some braid on this, some tape, get it all nice and ready, and then we'll put it in the car, and then we'll start working on these others. Probably wire the screen next, and the drive, reverse, neutral buttons. So we'll do probably everything on this harness, and then we'll do the other harness. Okay, so we're in the vehicle. Now my plan is, this is a little air conditioning vent and this is a digital clock. And what I'm gonna do is replace the digital clock with the OLED display that shows your charge, if you're in drive, reverse, neutral, etc. Your regen and all that is on this little screen. So I think it's gonna be really cool there. I could put it here on the dash. I could put it down here. I was thinking about putting it right here, but I think up here is good because it's going to be away, protected from damage. It's also going to be visible to like everybody in the vehicle because as you can see, I do have the full 8 seats in the Land Cruiser because I want to fill this up with all of my friends, take a bunch of people out on the trails and show them what electric off-roading is all about. So I think it's going to be really cool if I have this in plain view where everybody can see, ooh, look at our percentage, look at our regen, you know, things like that. So that's my plan. I think I'm gonna have to 3D print a little bezel to hold this guy in there because as you can see, I've got this apart and the clock just comes right out, and there's a couple little mounting holes I can use, and this guy should fit in here just perfectly as long as I can 3D print something. So that's my plan. I think it's gonna be great. Okay, so this is the stock wiring loom that I pulled from the Nissan Leaf. These are all the plugs that go to like the CHAdeMO, to the inverter, the PDM, the BMS, things like that. But there's also some other things. There's like the horn, there's the little courtesy light. So what I'm gonna do now is spread these out on the floor. I'm gonna cut away all of the protective sheathing and a lot of the tape so that I can separate and get all the plugs and everything separated so that I can only keep what I need and ditch all the junk that I don't need. And that's just gonna help make the wiring so much easier. All right, that was great. So I've got the harnesses all dissected. There's all the wire from the harnesses that I'm not gonna use. There's all the tape and shielding I cut off. I'll reuse that protective guard probably. So this is the BMS harness. This is the inverter harness. And this is the PDM or the charger harness. So I'll walk you through a little bit about each one. So the BMS is probably the most simple, and it's really simple, it's simple, it just takes time and you gotta be really careful about how you do it. But you just go through and I just label all of the wires just the same as I did on the Resolve-EV controller. Also, I bundled them. So on the right here, I've got all the wires that are going to go to the Resolve controller. On the left, I have the ground and the 12-volt power. So did the same with the inverter harness. So I'll show you one thing that you need to know when you're reading these pinout sheets is the orientation of the plug. So you might look at that and go, boom, there's my plug, and start going at it and cutting wires and destroying things and changing things and labeling things. But you would have it wrong and you would potentially cause damage. The correct way to view a plug like this is this direction, looking behind the plug where the wire comes out. So when you do it like that, you can see the blue and green wires here on the top right line up with the blue number 14 and 15. So that's, you can key off like this is number 42 there. So you can key it off that way, but just make sure you're not doing it this way. Another way to check is see you've got 2 contacts there and 3 at the bottom, whereas here you've got 3 at the top and 2 at the bottom. So always make sure that you look at your plug the correct direction. So this is the inverter plug. I did the same, branched off what's going to the relay, the ground, and then this is the plug that goes to down to the motor, and then this goes to the Resolve controller. So I did the same with that one. And then this is the PDM or the charger harness, and this is probably the most complicated. So I've got Chatamo J70's 1772 chargers, the Resolve-EV, and then we've got ground and power over here. And remember, you want to make sure all your CAN bus lines are twisted and stay twisted. And you'll want to make sure they usually have like or they always have 2 colors, one high, one low, and you always want to make sure that when you're wiring it, you get the high and low correct. So I just label as much as I can on the wires. So next step, I guess I'll show you this. So I already did the Chatamo connector wire too. So this is the Chatamo plug, and it's got a bunch of wires that need to go to the PDM to control that. So the next thing I'm going to do is start laying out all those wires that I just organized. I'll lay them out here into the truck where they're going to live and plug all the connections in, and then I will start figuring out where I need to extend wires, where I can cut wires short, where the best ground points are going to be, and then I think I'll go to the factory firewall location for the factory wiring and some stuff like that. So basically that's what I'm going to do next. I like to do it that way, lay everything out as it's going to be in the truck versus trying to assemble a wiring harness on the floor, because you're inevitably going to run into situations where you need to extend a wire or shorten one because you needed to go around something you didn't foresee. Also, when you lay it out in the vehicle, you'll be able to see the best places to put plugs if you need to have a plug, because I want to ideally have this so that you can take it out and put it into a different vehicle if needed. So if there's, for one reason, it makes sense to run a wire through like a hole in the body, you'd want to have a plug there so that you don't have to cut your solder joint or whatever you did to get that wire back out. So that's what we'll do. We'll go ahead and get started on that. I can't wait, man. This is where it's really coming together. The guts, the heart of the beast is going to be installed and connected up. Let's do it. All right, welcome in the motor bay. So we'll do some wiring. First thing I'm going to plug in is the PDM. It's a little special plug. You got to take out the little black part from the gray. There's these clips around the outside. Use a little screwdriver, like I use 2 at a time to get either side, and then that'll pop off. And then this part you put on first, and then that part pops in. Okay, we'll plug in the inverter now. The inverter plugs in just right behind here, no problem. This will go down to the motor, just right there. Just the motor right there. And then these go to the Resolve, the Resolve, the inverter, and ground. So that's probably the simplest wiring of all, is the inverter. Go or no go. Now the BMS, I'm gonna have to kind of use my best judgment about where I'm gonna put the BMS. So the battery module will be kind of where I'm standing, or the battery pack will be kind of where I'm standing. I think what I'll do is I'll have 12-volt battery here. So if I have to have the BMS outside the battery pack, maybe over here is a good spot for it. So maybe I'll have my wire simulated over here. so I can wire it in. The windshield washer fluid, I can get a smaller tank or whatever. Ditch that for now. But we'll go ahead and we'll just figure out where the wires want to go. Figure out which ones go to special places. And get everything living happily. All right, so just that simple, I got everything organized. Over here I have my Chatamo and my J7 1772, the charger plugs. I'll wire in those to the plugs that are already there on the harness, and they'll all just be in one nice clean harness down there. All these wires going across are gonna go into the Resolve-EV that we mounted inside the truck. So what I'll do is I'll make a nice loom that follows the body around, but for now I'm gonna point them towards where they're going. Then we have all the ground and 12-volt power lines ran here to where I'm gonna put the battery. And also I've got the inverter relay for the inverter that's gonna also be mounted over here. That actually runs quite a few things, the inverter relay. It turns on the Resolve-EV also. So I mean, that's really it. There's not too much else going on. You just have to have all the wires go to the correct spots where they wanna live and connect them and make them happy. And then once everything is nice and fits right, we'll probably pull it out of the truck and we'll wrap it all up and protect it nice and good. So we'll dive into that. I mean, we'll just get started on it. Why not, right? All right, welcome back to the Cruiser. I've been working on it the last couple days, working on the wiring. So let me show you a little bit of what I've been doing. So I've been making some nice looms of the wire from the PDM, goes across here. Also loomed up some of the wires. That this wire here connector goes actually down to the motor, but I put a nice loom on there. Looks like I'm gonna have to retape that. That's some crappy Chinese electrical tape. That's no good. And then this is a ground that comes over here. Got that nice and loomed. These are signal wires from the PDM that I'm going to go through the factory grommet. I'm gonna dissect that loom there and remove as much as I can. That it goes to the engine wiring loom. There's a couple things I want to maintain. I want to maintain the coolant temperature sensor, the oil pressure sensor wires, the fuel, like anything to do with the gauges on the dash. I want to maintain those because I want to use them in the future for different things on the car. First thing I can do is obviously use the temperature switch for temperature on any kind of fluid. I think I'm going to use it in my transfer case because that's the most critical. but I could use it on other things. And then that way we can reuse some of those gauges on the dash versus having to, you know, add a whole bunch of extra stuff around or just not having any gauges. It's just something cool to make the car a little bit more personal. So we're gonna finish up the wiring. You can see I've got, this is my Optima yellow top. Like I said before, I could use like a small motorcycle battery or a small lithium iron battery. Like that would be, you know, half the size of this or smaller and a quarter of the weight. But I want this because I'm gonna put a winch on this truck, because remember, this is gonna be an off-road, rock crawling, mud bogging, off-road beast, okay? So it needs a winch, and in order to run a winch, you need a big battery that can deliver a lot of amps, big surge, and it's a really strong battery. Of course, the Leaf has the 12-volt DC-DC converter in here. So this is actually the ground, and this is the power that I've shown before. And these two wires I'm gonna run to the battery. And of course, the Leaf, you know, outputs 12 volts. The only thing is that it takes time for the computer in here to calculate, you know, the voltage is dropping, it needs to increase. And also this needs some sort of battery to take up load and sag on it. So you wouldn't want to run a winch on a small electric or small motorcycle battery and the DC to DC in here, just like you wouldn't want to run a winch on, you know, your small motorcycle with a small alternator. Or even if you had a big alternator on your truck and you just had a tiny battery, it would be no good for the winch either. So that's the main point. I can run my winch, and any other accessories have a big battery to soak up the load. The DC to DC in the this Leaf PDM can actually put out like 2.5 kilowatts, I think, 2,500 watts. So it's a lot of power that it can deliver. So it'll keep the battery charged once that state has been achieved where the battery now needs to charge. The PDM goes into charge mode and starts ramping up the output power. Then it'll keep it fully charged and we can run the winch all day. It's just when you're putting those initial loads on the winch, especially if there's a big surge in the power draw. So anyway, we're gonna do that. We'll wire up the 12-volt wires. Also, what we're gonna have to do is pull this guy out, because underneath here, that you can see some of it here, this is the stock 12-volt battery wiring. So that's actually, because normally the battery was here in the Land Cruiser, so we need to pull out some of that wiring so we can extend it. Okay, so I got the 12 volt pretty much done now, at least on the EV side. Next, I'm gonna have to tie the chassis into my 12 volts. So I got the wires come from the PDM, they travel underneath there. Then I've got them up under the radiator support. I've got the wires extended in this sheathing across here. Then my positive wire comes about here. My negative wires come here, so this is the one that goes to the PDM, and then this is the new chassis. This is my new body ground here, and then tying into that ground, I've got the harnesses from the inverter and the PDM, and then also I'm gonna have to tie my BMS grounds there also, but I'm gonna wait until I have more battery stuff, because remember, I'm gonna use a 30 kilowatt hour battery, so I gotta buy another Leaf. I don't have that Leaf yet, I don't have my battery yet, and I'm just blazing the trail forward anyway, so hopefully we get it done right. So that's my 12 volt system. These wires are 12 volt wires that go to the PDM, and then these is 12 volt for the inverter and the energizing 12 volts for the relay for the inverter, which is like the ignition, turns on the whole car. So what I'm gonna do is I've got a little fuse and relay box here, and what I'll do is put run all those 12-volt connections into this relay box, and then each connection will be fused and the relay will be in there, and I'll also be able to put some accessories in there like lights and stuff like that. So we'll run that, we'll put that up over here out of the way and make it all nice and professional and protected. So I've been jamming, and we got the 12-volt system completely wired up now in the electric Land Cruiser, which means the battery here now will power the lights, the wipers, all the accessories, the air conditioner, the heater, all the fans. I'll go ahead and I'll turn everything on for you. You can see we already got lights in here. We got beeps. We got all our stuff on the gauge cluster. Look, so we got wipers. Awesome. We got windows. All 4 windows we can roll up and down. Keeping them down for now. Sunroof. Oh, wrong one. Slider tilt. Which one? Here we go. Sunroof works. Awesome. The dome lights work. The heater, full blast. Oh, there's dirt in it. Works. So everything now works. It's wired up on the truck. I'll even turn on the hazards just so we got something going. The horn works. We got tail lights. We got brake lights. I checked them already. Just everything's now working. This is a super big moment because now we can press on with all the high voltage wiring and all the EV stuff, because now it's a vehicle, fully functional. We just have to make it run. All right, so as we come in closer, we've got the 12-volt battery here. This is what was just powering all those accessories. So this is just a normal car battery. And here I've got this taped off because this is the positive from the PDM that will actually charge the battery. This second wire here is the body positive movement. The body positive wire, that's what actually powers all the accessories that we just tested. So this, what I had to do was extend this cable, run along here, and then we bolted on a lug down to the factory connection point there. And now what that wire does is it goes up here to the main fuse box for the Land Cruiser. So now if I was a little bit more clever and I wanted to do this a little bit cleaner, so you'd say, I could use some of these fuses, like for the EFI relay, the fuel injection computer, like things like that I'm not using. I could repurpose those relays and fuses for the EV stuff, but I'm not that clever, or at least I don't want to do that, get that into the weeds on my first build. I really just want to get this truck running, even if it's a little bit caveman style. So I showed you before, but I've got this fuse box, and this is gonna be all of the aftermarket fuses and relays for everything. So the inverter needs a relay to turn on when the key turns on. I'm also gonna get a vacuum pump, and I'm going to get an electric pump for my transfer case to keep it cool. And I'm also going to get an electric Volvo power steering pump. I think that's the direction I'm gonna go with that. It's a 12-volt power steering pump, can be adapted to any vehicle. I just need to get the high pressure and low pressure lines adapted to fit, plug into the Land Cruiser. But that's a little bit down the road, but I've got that going. So the fuse box is gonna have all the fuses and relays for those systems as well. So we'll get back into it. I only have a handful of wires left in the low voltage system that are gonna go through the firewall, and I think I'm gonna mount that VCU behind the dashboard. I was gonna put it in the center console, but I think it's gonna be better behind the dashboard. So I'm gonna go through that firewall grommet there, where the harness that I cut all the the engine harness, I just chopped it, which is not the most clean way to do it, but you know, you gotta do what you gotta do. I'm gonna take this, clean it up, cut it out, keep a couple wires that go to various things I'm keeping, the rest of it go, and all the wires I'm gonna run in through that grommet there. So that's the next step on the list, to get all the low voltage wiring completed. So let's get into it. All right, so I've got the wire run to the grommet here. You can see the wiring for the Resolve-EV there and here. And then I've got to run the BMS wiring, but I need to extend that because it's not quite long enough yet. And then inside the glove compartment area, I've got the Resolve mounted just right here. I think that this is going to be a better spot for it than the center console. You can see the wiring just comes out right through here, super simple, through the firewall. And then I have short runs to run from the Resolve to the switches and to the OLED display, which is going to be up here. I think that's going to be better than in the console, just because it's going to end up with shorter wires overall for everything. And that's the factory ECU location where the factory computer is, so should be protected from water and all that. I did find when I was pulling all this crap out that there was a Motorola like phone, I guess, thing. I'm gonna Google this, see what it is, but it's old and gross and got tons of wires that were just all over the place. So I don't know, maybe that's worth some money on the internet. Like people are into like old classic hardware like this, and maybe it does something that a modern phone system can't do. So I'll just figure that out. But anyway, it's coming together. We'll start wiring in the plugs here under the dashboard, and then wiring and everything else, you know, we're just wiring. It's an electric car, you wire it. So I'm sitting here wiring up my VCU and going through the instructions, and I realize now that I have to cut out and redo some of the connections I've done here, because I want to use the OBD connector for Leaf Spy, which is a really cool feature of the Resolve, where you can use Leaf Spy to tell you all your battery stats, health, how many amps you're pulling, you know, everything about it. The thing is that this is the very last page of the instructions, and it tells you that you need to parallel the connection with another CAN bus connection. So I got to undo one of my CAN bus connections so I can put that on there. So I'm going to go ahead and do that. So just so you know, if you're wiring up your VCU, make sure you do that OBD plug before before you start thinking you're done. All right, I got my relay and fuse box built. I was gonna label it all nice, but I only got one label before I ran out of tape. But what I've got here is 6 fuses, 6 relays. Currently, I have 4 fuses straight into the relays, and then 2 fuses are just pass-through fuses, and 2 relays are not being used. So what I've got is the inverter relay, the vacuum pump relay, power steering pump relay, and the transfer case coolant pump relay. And then for the fuses, I've got fuses for the inverter back, PS, and T case, all those relays. And then fuses for the PDM and the BMS, and for the Resolve-EV controller. So that's my little aftermarket fuse box. I get it all nice and heat shrink and waterproofed and everything. I got my other wires labeled so that when it's mounted I can hook up all those peripherals, and we'll go ahead and we'll install this in the truck so that we can finish up the wiring. The wiring's coming together real good. Just about done with the Resolve VCU wiring. Let me show you a little bit about what's going on. So I was able to pull the wires through the factory grommet, which comes through the firewall and comes in here. So I will bundle these up and put some nice sheathing over it. But so I got them all pretty much wired up except for a few circuits. These ones, which are twisted pairs, these are for the CAN bus. So one of these is for the inverter, one is for the BMS, and one is for the PDM or the charger. And that's how the VCU communicates with those. Then over here, the 3 connections I don't have hooked up yet are the radiator fan relay, the brake lights relay, and the reverse lights relay. So those 3, probably do those tomorrow. Got a ground, nice ground. This is the overall ground for the Resolve-EV VCU. So that's gonna have a nice solid ground connection. So that's really it on this plug. All these connections here go to those 3 things: the VCU, or I'm sorry, the PDM, the inverter, and the BMS. And also we pull in 12 volt power here as well. And then one of these is a relay for the inverter, turn the relay for the inverter on. So that one nearly is done, just 3 connections left on there. Then on the other plug, this is more of the user inputs side. So I've got this twisted pair here, which is gonna go to the OBD connector so that we can pull in the OBD information through LeafSpy. Then that's shared with this cable, which goes to the OLED LED display. And this cable is actually that HDMI cable that or the USB. I think it's the USB. It's either USB or HDMI, I can't remember. But shielded, really good shielded, high quality cable. And then since it's shielded, I have a ground for the shielding that I'll tie onto the other grounds. Also, we've got the brakes, 12 volt in, so when you push on the brake pedal, the car puts out 12 volts to like the lights to turn the brake lights on, the relay, so that 12 volt we want to put in here so that the Resolve knows when you're braking. I may put a disconnect on that because the way I understand it is that it reads when it sees a brake input, it won't let you use throttle. The Nissan Leaf was the same way, but I want to use the brakes and throttle at the same time. It's called left foot braking for off-road driving. It's very useful and can get you out of certain situations. It helps to drive the differentials, drive each side of the differential together with those brakes, and also you can do some other techniques with left foot braking. So I might try to put a disconnect switch into that. I'm not sure if it's going to function without that, but I assume that it would just never see the brake input. But it would be nice to have that for around town driving, just so there's no unintended acceleration events. Okay, so then the last thing that we have is the neutral, reverse, and drive switch inputs. So I need to mount those. I think they're going to be in the center console area. 3 push buttons for drive, neutral, and reverse. So you just push the 3 buttons. And then the last connection on here is for the throttle. So this is for the Volkswagen throttle. And again, I used high quality HDMI or USB, I forget, cable for that. And that also has a little ground tab. So that's basically a little walkthrough of the Resolve wiring. Pretty much almost done. Just a few more things to do, and I'll probably get those done tomorrow. So that's my goal. Other than that, man, just pushing forward. It's getting really close now. It's getting really close. This is like the tedium, all these wires, you know, the monotony, the minutia, monotony. But anyway, so this is the devil's in the details. You get these things right though, and then as soon as you apply power for the first time, it just works instead of having to chase gremlins. So that is the idea. Oh, I'm tired. I think I'm gonna head home for the night, and I'll see you back here in the morning. Welcome to the wiring table.